Today's video is going to cover Section 3.3, Day 1, which is going to talk about the rules for differentiation. So hopefully yesterday in the GeoGebra activity you actually came up with some of these rules. So this video is just to solidify those, make sure we all have a common understanding of those rules, and then do a little bit of practice. Okay, so here's the rules we know so far. First one is our constant function rule, and that says if f of x is equal to c, which is just a constant, we know that our derivative is equal to 0. Right, which makes sense. Let's think of a function f of x equals 2. We know the graph of that function is just a horizontal line. And since the slope of a horizontal line is 0, it makes sense that that derivative would be 0. So that's our first rule. Second one is if we have a constant times a function. So if my function f of x is a constant times another function, my derivative is just that constant times the derivative of my function. So I can essentially just pull that constant out front and take the derivative of my other function. Next one is power rule, and that's going to be a big one for us. It's going to save us a lot of time when we're calculating simple derivatives. And that looks like this. If I have a function f of x equals x to the nth power, then my derivative looks like this. I take my exponent and multiply it by the coefficient of x. So in this case, my coefficient of x happens to be 1, so n times 1 is just n. My variable is x, and then my exponent I take 1 away from is n minus 1. And we'll do several examples looking at that today. And then I have a sum and difference rule for derivatives. So if my function is the sum or difference of my functions g of x and h of x, then I know f prime of x is just the sum or difference of their derivatives. Okay, so these are our rules, or really our shortcuts that we have at this point. So let's go ahead and just do some practice with some basic examples, and you'll have plenty more practice to do tomorrow in class. So first, let's take a look at number 1. Okay, and so here I have a basic polynomial function, and so we want to find the derivative. So since my function is p, I'm going to call this p prime. And I'm going to use my power rule here. So my first term, my exponent is 3. My coefficient of t is just 1. So my first step is to take the exponent times the coefficient, which gives me 3. My variable is t, and then I reduce my exponent by 1. So now what was 3 becomes to the second power. My next term, again, I take my exponent and multiply it by the coefficient of t. So 2 times 6 gives me 12. My variable is t, and in this case, if I subtract 1, my exponent is just 1, so I just leave that as 12t. And notice I'm just taking the derivative of each term separately. This is somewhat applying our sum or difference rule here. Now here, minus 5/3 t, right? We know that this exponent is just 1, so I'm essentially just multiplying 1 times a negative 5/3. So I just have negative 5/3. And now, if I reduce this exponent by 1, I have t to the 0, which is just 1. So that term, the derivative of negative 5/3 t, just becomes negative 5/3. And since my last term is a constant, we know the derivative of a constant is 0. So I have plus 0, or we just leave that there. So that would be our derivative for that problem. Okay, so now we can look at number 2. So my derivative, y prime. Again, we're just multiplying the exponent times the coefficient. So I get 4x, and then when I subtract 1 from my exponent, I get 3. Minus 2 times 2 gives me 4x, and I'm to the first power now when I subtract 1 from my exponent. And for the last term, the derivative of my constant is 0, so we're done with that derivative. Now the only difference with number 3 is now we have some decimals. But as long as we can do basic multiplication, it's no different. So for y prime, again, I just have 4 times 0.2, which is going to give me 0.8 x, my exponent becomes a 3. For my next term, I multiply 3 by my negative 0.7, and I get a minus 2.1 x to the second power. And then my last term, my 5x, again, we can think of this as having an exponent of 1. So I'm doing 1 times 5 is 5. If I decrease that exponent by 1, I get x to the 0, which is just 1. So the derivative of that term is just 5. And we're all done. Now, with fractions, it may help if you simplify or rewrite some of these fractions first to help you find the derivative. So that's what I'm going to do here. First, I notice if I have x cubed over x, I'm going to simplify that to x squared. And my next term, instead of x squared over 2, I'm going to rewrite it as 1/2 x squared. And then my last term is plus x. So now we can see, even though maybe it looked a little more complicated, we still just have a basic power rule formula here. So we can apply that. I get 2x for my first term. My second term, I'm going to multiply 2 by 1/2, and I just get 1. So plus x, and that's to the first power. And here, my coefficient and my exponent are 1. So when I multiply those, I get 1. My x goes to the 0 power, so that x drops out. And there's my derivative. So that's the basic of these general derivative rules. We're just going to look at some slightly more complex examples to finish out the video. So on page 32, we're going to talk briefly about finding derivatives with variable denominators or rational exponents. So the first thing, if I have a problem like this, I'm going to rewrite all of my powers so that I have negative or rational exponents, meaning I write my exponents as a fraction. Doing this will allow me to just apply the power rule and then rewrite my answer if needed. So let's take a look at some of these. See if I can zoom this a little better. Okay, so my first one, f of x equals 4 over x to the 4th minus 3 over x cubed. So again, this looks complex, but I can simplify things quite a bit by rewriting my fractions with negative exponents. So I know x to the 4th is positive if it's in the denominator, but I can rewrite it in the numerator by making my power negative. So this becomes 4x to the negative 4th, and I could do the same thing with my second term, minus 3x to the negative 3rd. And now it's really easy for us to go ahead and apply our power rule. Now to find the derivative, f prime of x, I'm just back to multiplying my exponent times my coefficient. So I get a negative 16, my variable's x. And now here's where I have to be really careful, and here's where students tend to make mistakes. I'm still subtracting my exponent by 1. So I want to be really careful. Negative 4 minus 1 is a negative 5. Make sure you don't end up accidentally adding 1. We're still subtracting. So I'm going to handle my second term the same way. A negative 3 times a negative 3 gives me a positive 9. My variable's x. And then when I subtract 1, I get to the negative 4th power. And so now I'm just going to rewrite this. And I know that f prime of x, I'm going to make all my exponents positive again. So I have negative 16. To make that exponent positive, I'm going to drop it down to the denominator. And I'm going to do the same thing with my second term. And that's my derivative. We're going to apply this same concept here when I have radicals with my variable. So I'm going to rewrite this. Instead of saying the square root of x, I'm going to write it with a fractional exponent, and I know that square root of x is just x to the 1/2. So then you can see really easily here that we can apply the power rule. 1/2 times 3 gives me 3/2 times x, and then 1/2 minus 1 gives me to the negative 1/2. So now I can rewrite this again. I can rewrite my 3 is going to stay up top, my 2 is in the denominator, and now I'm going to bring my x to the denominator to make that exponent positive. And I could go one step further and write it as 3 over 2. Instead of x to the 1/2, I'm going to write root x. And that's my derivative. So we just have 2 examples left. And again, same idea here. We just want to be careful when we're making those rational exponents that we're writing them correctly. So again, my first step is going to be to rewrite this problem. So 3 is going to stay the same. If I have the cube root of x squared, that's just going to become x to the 2/3. So now, to take my derivative, I'm going to multiply 2/3 times 3, which is just going to give me 2. My variable's x. And if I subtract 1, which is the same as subtracting 3/3, my exponent becomes negative 1/3. So now, just like above, I'm going to rewrite this. 2 will stay up top. That negative exponent is going to come down, become x to the 1/3. And then I could write this as 2 over the cube root of x. And that's my derivative. So now for the last one, we're just kind of combining this idea of converting our problems with negative exponents and fractional exponents. So this I'm going to turn into x to the negative 2 plus 5 times x. In this case, it's going to be to the 4/3 power. So notice I haven't used my derivative notation yet because all I've done so far is rewrite f of x. So I don't want to use my derivative notation here. However, in the next step, now I can indicate that I'm finding the derivative of x, or of f with respect to x, and I use my power rule. I get negative 2 times x to the negative 2 minus 1 is negative 3rd power. When I multiply my exponent by my coefficient, I get 20 over 3 times x. And now here when I subtract 1, 4/3 minus 1 is the same as 4/3 minus 3/3, so I have 1/3. If I wanted to rewrite that, the negative 2 would stay up top, x cubed would go into my denominator, and I have 20 over 3 times the cube root of x. So those are the types of problems that you'll be practicing tomorrow in class. And really, even though the rules are not complicated, what we're looking for here is to get really quick with these basic types of problems. Again, this is a skill that we really need to be automatic. See you tomorrow.